Good morning all. My name is Radhanath Devi, first year MSc Food Technology student. Here I am going to take my topic on inductive heating. First we can go through the content of this PPT. First introduction, principle, how it's work, heating mode, applications, advantage, limitation, conclusion and reference. First we go through the introduction. The basic principle of induction heating was being understood and applied to manufacturing since 1920s during Second World War. It is method of rising the temperature of electrically conductive material by subjecting to an alternating electromagnetic field. It is a contactless heating process. It is a high frequency heating process. We use approximately not more than 1 kilohertz. In case of micro particle or micro pieces, we use about 480 kilohertz. Let's the heat generated in the material is proportional to frequency and intensity of magnetic field, the material's electrically conductivity and its magnetic permeability. Induction heating allows for precise temperature control and is highly efficient as it does not require any physical contact between the heating element and the material being heated, reducing heat energy loss. Induction heating is used in a variety of industries including automotive, aerospace and medical device manufacturing, where it is used to improve the property of materials, reduce production time and improve efficiency. This is the man who invented this. This is Michael Faraday. Let's Inductive heating is working on two principles. First one is Faraday's law of electromagnetic and concept of Joule heating. First look what is Faraday's law of electromagnetic. First law, it states that whenever there is a change in magnetic flux associated with a coil, EMF is induced in the coil. EMF means electromagnetic force. Second law states that the magnitude of EMF induced in the coil is directly proportional to the rate of the change of magnetic flux associated with the coil. Concept of Joule heating. Joule heating is the physical effect by which the pass of current through an electric conductor produces thermal energy. It is an easy concept. Let's check how it's work. The induction heating process work by creating a strong magnetic field using an alternating current AC that flows through a coil of copper wire. This coil is called induction coil and is usually made of copper tubing or wire that is spooled into a spiral shape. When the alternating current flows through the coil, it creates an oscillating magnetic field that passes through the working piece inside the coil. As the magnetic field passes through the conducting material, it includes an electrical current or eddy current in the material. This current flows in circular pattern, generate heat due to resistance of material. The heat generated by the eddy current is proportional to resistance of the material and intensity of the magnetic field. The heating process can be controlled by adjusting the frequency and intensity of the alternating current as well as distance between the coil and the workpiece. By adjusting this parameter, the temperature of the workpiece can be precisely controlled, making induction heating a versatile and efficient heating method. This is a picture how it's work. It's a simple diagram. This is a small setup of induction heating. Let's check the heating mode. There are two modes in induction heating. One is static and another is continuous heating. Static. Let's check static. Workpiece is placed into an induction heating coil for a given period of time and set the amount of power is applied. The symbol. Continuous heating is workpiece is moved continuous through one or more induction heating coil. Applications. Induction cooking. The circulating current in the metal pan on the top of the induction coil directly heat the pan. It's a simple concept. Copper bottom pan, aluminum pan, or other non-ferrous pan are generally unsuitable. Induction cooking is highly efficient with up to 90% of the energy being transferred to the cookware compared to only 50% of gas and 65% of traditional electric stove. The heat is also highly responsive with the ability to adjust temperature quickly and accurately. This is a simple picture or diagrammatic representation of induction cooking. Let's check what is induction heating. It is a non-contact method of heating a metallic disc to hermetically seal top of the plastic and glass container, to reduce induction sealing, leak prevention, freshness retention, and sustainability. This is a simple diagram of induction sealing. Let's check milk pasteurization using induction heating. Rise milk temperature faster than traditional method. Destruction of total bacterial load of fast 99.5%. Cold fermented Escherichia coli count can be 1 by 10 of traditional method. Fouling was not produced due to fast heat transfer. Other applications are used. This induction heating is used in induction food burner, induction extruder, heating of roller, cancerization, bio-oil production. Advantages. Let's check one by one. First one, fast heating. Induction heating is a rapid process that can heat material quickly and efficiently. The heat is generated directly in the material, so there is no need for transfer of medium such as air or water. Precise control. Induction heating provides precise control over the heat process, allowing for accurate temperature control and heating profile. This is particularly useful in application where precise control is such as in metallurgy and material science. Energy efficiency. Induction heating is an energy efficient process that minimizes the heat loss and can reduce energy consumption compared to the other heating method. This is because the heat is generated directly in the material rather than being transferred through a medium, which can result in significant heat loss. Clean process. Induction heating is a clean process that does not produce emissions such as greenhouse gas, make it an environment friendly option. Low maintenance. Induction heating equipment is relatively low maintenance and has a long service life. This is because the equipment does not have any moving parts that require regular maintenance or replacement. Another one is this is versatile. Induction heating can be used for a wide range of applications, including heating metals, plastics, and glass. Make it versatile. It is particularly used in application where traditional heating methods such as flame or oven heating are not suitable. Limitations, material limitations. Induction heating is only efficient on material that are electrically conductive, which means that non-metallic metal cannot be heated using this method. Depth of heat. Induction is not suitable for deep heating of material. The depth of heating is limited by the frequency of electromagnetic field and material energy electrical conductivity. Equipment cost. Induction heating equipment is often more expensive than other heating methods such as gas heating or resistance heating conditions. Power consumption. Induction heating requires a significant amount of power to operate this can result in high energy cost. Safety concern. Induction heating can pose a safety risk due to high voltage and current involvement. Proper training and safety measures must be in place to prevent accident. Design complexity. Induction heating require careful design and optimization of electromagnetic coil, power supply, and other components. This can add complexities to the system and increase the design and manufacturing cost. Conclusion. Induction heating is a process that involves heating a conductive material, inducing electromagnetic field within it. This process is efficient, fast, and has wide range of applications included in manufacturing industry, metallurgy, and material science. Induction heating is a non-contact heating process that offers several advantages over a traditional heating method, including improved energy efficiency, precise temperature control, and reduced process time. It is a reliable and versatile heating method that can be used to heat a wide range of material and is increasingly heavily used in various industrial processes. These are the references. Thank you.